But my name is Jared Degater. I'm an application expert out in Lafayette, Louisiana. And just to introduce myself a bit further, prior to coming on board with MLC, I spent 7 years working in the oil and gas equipment manufacturing business, designing equipment similar to what you see in the bottom right corner using SolidWorks. So got a lot of good real-world experience there. Received my master's in engineering and technology management from Louisiana Tech. Spent 6 years in the National Guard, a year of which was overseas. It's actually a picture of me and my dad. We ended up deploying together in 2010. And other than that, I'm interested in just about anything outdoors and fitness related. But enough about me. Let me introduce you to the star of the show, MLC CAD Systems. MLC is one of the largest VARs in the US, and what VAR stands for is Value Added Reseller. So SolidWorks kind of distributes its products through a dealership network, if you will. And what that does is it allows SolidWorks to focus on making great software, and it allows MLC to focus on providing unbeatable service. So we provide things like training, technical support, software implementations, things of that nature. But I just want to elaborate a little bit more on unbeatable service. That's our motto for one, but it's also something that everybody on this team takes to heart and really strives to provide. So hopefully you've had the experience to work with us and have got to experience that. And if not, hopefully we get to work together in the future. And this is just a quick warning here. You might love CAD completely after this demo. Get it? MLC, CAD, it's an acronym. Nobody? Tough crowd today. Anyway, moving on. As everyone's aware, SolidWorks comes in 3 different versions, right? We've got our standard, our professional, and then our premium. And what we're going to be exploring today is one of the add-ins inside of the premium version of SolidWorks called routing. And routing is just an awesome tool that can really help expedite your design process, help you become more accurate for your routed pipe systems, for tubing systems, even hydraulic hose and electrical. But just to give you guys a little outline of what we're going to be covering today, we're going to focus on the routed pipe systems, just due to time constraints, we can't touch on everything inside of routing. But we're going to look at how to create a pipe route, how the lengths of all of those joints of pipe that you're going to need inside of that route, how they're automatically calculated. So you automatically have a materials takeoff. And then after that, we'll look at separating different portions of that route into spools. That way we can easily fabricate them. And then generating an automatic drawing with an automatic bill of material created. So that's what's on the agenda here. I'm going to switch over to my SolidWorks screen now. All right, so what we're looking at here is just a little process station. And what we're interested in accomplishing is creating a pipe route, a fabricated pipe route, that's going to tie in these highlighted nozzles. It's going to tie those nozzles in together. So we're going to come out from here, tie these 2 in together, and then we're going to kind of follow, this route's going to kind of follow around this retaining wall, and then terminate over here on this larger, this nozzle over here on this larger tank. So that's kind of, the general overview of what we're going to do here. And one of the things I really like to do before routing inside of a larger assembly is leveraging something called a display state. So sometimes whenever you're dealing with a larger assembly, you can kind of get into a cluttered situation where you can't really see and access what you need. And that's where display states really come into play. Basically, they hide the clutter. That way you can focus on what you need to focus on. So I'm going to kind of rotate around under here to where I can see these 2 bottom nozzles a little bit more clearly. And I'm going to leverage something called a design library to just drag and drop the required parts into my assembly, and that's going to actually start my route. So design library is a great place just to store commonly used components that you can share with your team. That way you can kind of help to reuse existing components and prevent duplication of work. And what I'm using right now is just the out-of-the-box routing. The library that it comes with is really really pretty nice and easy to use right up front. So right here, I'll go ahead and demonstrate how easy it is just to get started with a route. It's as simple as dragging and dropping. And I want everyone to notice just how the flange that I'm dropping in automatically mates itself to the nozzle. And in addition to that, it's also going to automatically size itself. Notice that I'm only getting 5-inch pipe sizes here, and then I just have to select whatever class I'd like to use. So I'll go ahead and click OK to confirm that. And this gets me into the route properties area where I have the ability and flexibility to select things like if I wanted to change up the schedule that I was using for this pipe route. Maybe I wanted to automatically include weld gaps or use a standard length of pipe. You can even come in and select what type of elbow you'd like to use. So really a lot of flexibility here that you have available, but you also have the availability to create a template, and I'm going to go ahead and leverage this template that I've already created. That's just going to set this up to use Schedule 40 pipe along with some particular 90-degree and 45-degree elbows. So a little time saver right there just to have a template set up. And once you click OK, you get brought into the routing subassembly. So you can see the subassembly gets created right here in this area, and we're basically designing this route in the context of our large assembly. And what I'm interested in doing, I want to come in and drag and drop in another one of those flanges, because this is another area that I'd like to tie in. And just to finish things up, I'll go ahead and add in the nozzle on the larger tank as well. And notice how whenever I drop these in, a little pipe stub automatically comes off of there. And I can use those to then route wherever I need. So there's a couple of different methods that you can utilize to route around with and how to define where your route is going to take, where your route's going to go. And one of those is just doing 3D sketches. So pretty simple. If you've ever done any type of 3D sketching, I'm just going to come in and grab this endpoint, that endpoint of the stub, and sketch wherever I'd like this route to go. I'll do the same thing over here. And what I want to highlight is the fact that wherever I drew this 90-degree angle, a radius gets automatically added in. And that radius just so happens to perfectly match the radius of the elbow that I had selected in this route. So it automatically gets created and placed right there. Pretty nice little deal. I'll go ahead and continue, just designing our route here for a little bit. So like I said, pretty simple process just to come in and use your basic 3D sketching. Now, what we're going to want to do here, since I have a segment of this pipe kind of terminating into another segment, what we're going to have to do is add in a T. And once again, you can just go right back to your design library and then click on your T's folder, and you have a couple of options here. You have either a reducing or just a straight pipe T, and I'm just going to drag this in. Notice the automatic orientation though. So it automatically orients itself, and it picks up on the fact that, hey, this is a 5-inch piece of pipe, so I'm only going to give this designer options for a 5-inch piece of pipe. So I'll go ahead and click on the Schedule 40 for the 5-inch there, and that kind of knocks that out for us. Now, what happens if we want to come in here and we want the elbow to be welded directly to the weld flange? Well, you have some flexibility here as well. You can just come in and remove those pieces of pipe, and it kind of just snaps right into position from there. So like I said, a lot of flexibility. I'm going to hop out of the actual route for a second because I just want to clearly demonstrate what's actually happening right here. So I'll jump out of the route, and I want to bring to everyone's attention the fact that these elbows, those are their own components. Those will show up in a bill of material, but those automatically get placed wherever I made that 90-degree bend. The other thing that's going on here, I'll kind of expand my feature manager design tree for a second here, is that inside of this route subassembly that we've created, all of the components get grouped into this little folder, so it's very well organized. And then the actual route parts, which are the joints of pipe, get placed into their own folder as well. And the beautiful thing that's happening in the background is that the cut length for all of these joints of pipe is getting calculated automatically. So all of that information is right here for us, and it updates on the fly if you ever make any changes. So that makes it really easy to come in and leverage that information whenever we document our design, and I'll showcase that in a little bit. All right, but for now, we got a little bit more routing work to do, so I'm going to jump back into this route and continue along with our design. Let's get a little bit more visibility because we're going to want to reference some of this geometry as we're designing along here. By the way, I failed to mention, you can, of course, dimension any of these sketch segments to kind of call out how long you want this route to be. So that's perfectly easy. I'm not going to focus too much on the dimensioning aspect of things, though. So that's a little bit more mundane. But I do want to showcase the auto route capability. So auto route is basically just what you would think it is. It's going to allow you to automatically route your designs. And the part of this that I'm going to demonstrate first is the ability just to route along geometry. So this just lets me select an offset dimension. In this case, I'm going to select 4 inches. And then any of the geometry that I click on, the software is just going to offset it by that value from that particular selection. So take a look. I'm going to go ahead and I want to kind of follow this retaining wall that we have here. So I'm going to go ahead and just click on this wall right here. Notice the route snaps into position. If I want to make a turn, and like I said, I'm following the retaining wall, I can just come in and make this selection over here. And what's great about this is that it gives you the ability to flip the offset direction. So if I want, I can just simply right-click, and the offset direction changes to either side of that selection. Pretty nice, pretty easy. I'm going to continue to kind of route along over here. And then we're going to go ahead and confirm from there. So route along geometry just kind of makes it really nice and simple to follow existing geometry. And just to showcase another ability of the auto route functionality here, I'm going to go ahead and I'm going to just use the standard auto route mode in this case. I'm not going to be routing along any geometry, but I'll go ahead and I'll select this endpoint of my route, and then remember we wanted to terminate that route over here where the larger tank is. So from here I'm just going to select the other endpoint of this route and check out what happens from here. It goes ahead and it automatically solves using an orthogonal type of route, and I have the ability to select multiple types of routes from here. Now not all of these are going to be perfect, of course. You still have to use a little bit of common sense here. But it's going to come in and really give you an array of selections that you can use for your route. And in our case, this is the one that I'm looking for. So I'm going to go ahead and confirm that from here. All right, so that looks pretty nice. I'll go ahead and just add in a dimension to kind of be a little more fully defining here. Let's just say we want that to be 1 foot 6 inches. All right, that looks good from here. I'm going to hop out of the route again just to kind of take a look at what we've got so far. All right, so our pipe route is starting to come together. We've used some route along geometry to kind of easily define where we wanted it to go, and then we auto routed it from there, and it gave us a nice looking orthogonal type of pattern. So one other piece of functionality that I'd like to show here is the ability to easily add a slope to a joint of pipe. You know, like maybe you have a drain pipe or something and you need to add a particular type of slope. And I'll go ahead and demonstrate that real quickly here. I'll come in and, you know, once again, I'm just using some basic sketching. I'll tie in this little drain pipe right here. Let's go ahead and drop in a T for us while we're at it. Once again, I want to draw attention to the automatic orientation and size selection that's going on here. Makes it pretty nice and easy to drop in our fittings where needed. And let's go ahead and add a little dimension here. We'll just drop that in at 10 feet. But let's say we want this pipe that I just added to slope at a predetermined type of angle. And we basically just come up to our toolbar again, hit our add slope, select which portion of the route that we would like to add that slope to, select the gravity plane, which in this case, we're just going to select the ground, if you will. And then you select the start point where you'd like the slope to begin. And at that point, it'll give you a nice little preview. You can see the yellow line is where the new pipe route is going to be. Of course, we do have the ability to flip that back and forth. So I'll go ahead and flip it to where the slope is going down. But we're just going to go put a 1/30 slope right here. Go ahead and confirm that. And there we have it. Our slope is created. I'll kind of move into a better angle so everyone can see this. Oh, there we go. So you can see there's a 1/30 slope, and it's pretty much as easy as what I just demonstrated. So pretty nice little feature, piece of functionality there. Now, one other area that we need to come in and demonstrate is what happens if you're going to have multiple pipe sizes inside of the same route. So for instance, what if I wanted to tie in this little nozzle that was right here and tie that into my pipe route? Now this is a 5-inch piece of pipe, and that's a 2-inch nozzle. And I'll go ahead and kind of demonstrate real quickly what our options are. I'm going to go back to that design library and drag and drop in another weld neck flange. Now take a look at what happens here whenever I do this. The sizing, even though I'm in a 5-inch pipe route, it automatically sizes it and picks up on the fact that, hey, that nozzle is only a 2-inch pipe size. So I can just come in, select that. We can hit OK. And the software is, of course, intuitive enough to understand that when you have a 2-inch flange, you're going to want to use a 2-inch piece of pipe. So it's pretty intelligent in that regard. And we want to tie that in over here in this area. So I'm just going to come in and we'll do a little auto route from that point to this new point. And the software is going to warn us. It's going to say, hey, the selected route segments, they are different sizes. So you're going to need to do something to address that. I'll go ahead and run with this for now. Let the auto route kind of solve this. All right. And we want this to be pretty straightforward. So let's go ahead and add a sketch relation just to make sure we're maintaining perpendicularity between those two routes. After that, we'll come in and we'll drop in a reducing T right here. Once again, automatically orients and it automatically picks up on the appropriate size, a 5x5x2. All right. Now, I want to draw a little bit of attention over here to this elbow that we have. Now, this elbow is not a 90 degree or a 45 or a 30 or any type of standard, angular type of elbow. And we have a couple of ways that we can address a problem like this. I'll go ahead and exit out of this route to demonstrate that. So it's going to flag us. It's going to say, hey, we don't have a matching elbow. We don't have a 90 degree or a 45 or anything like that in our library that kind of fits this because this is a 51.9 degree angle. So you have options, as you do with everything else in SolidWorks. You can either make a custom elbow or you can just bend that joint of pipe. And that's what I'm going to do here just to kind of keep things simple. I'll go ahead and just select that I want to make a bend at that point. And when we hop out of the route, you can see that that joint of pipe now is just basically bent instead of including an elbow. So pretty flexible, kind of gives you all the tools that you need to make whatever type of designs that are required. Let's jump back into the route. Now, of course, we haven't really put any type of fittings or valves or anything into the route at this point. So let's see what that looks like. You guessed it, back to the design library. Except this time, I'm going to jump into the valves area. And let's say we want to have a little ball valve right here. That way we can kind of shut off that flow when needed. So once again, it's just as simple as dragging and dropping. And then you do also have the flexibility to adjust the angular orientation of that particular valve that you're dropping in. And you can do that just by using your arrow keys. We'll go ahead and place that. Whenever you drop in a valve, the great thing that happens here is that the pipe also gets split at that particular area. That way you keep an accurate cut list of what your pipe lengths are going to need to be. So pretty sharp right here. Let's go ahead and we'll drop in a few more of these just to kind of make our design look nice and pretty and be a little more functional. Once again, of course, you can rotate all these around. That looks pretty nice here. And then let's go ahead and we'll add a check valve between these two, and then add maybe another valve here to shut off our drain pipe whenever we need to. Once again, these are all just default components that come with SolidWorks. So this is nothing that you have to go in and build. It's pretty much out of the box. Now, with that being said, you do also have the flexibility to customize and create custom fittings, custom valves. You can basically customize it to meet any application that you may need. So pretty, but like I said, once again, pretty nice just out of the box. All right, let's jump out of this route. I'm going to go ahead and open this in its own window. But we can kind of take a look. You can make sure you don't have any type of interference. Of course, you could turn on all the rest of your other geometry if you needed, just to make sure nothing kind of runs into anything. That's one of the beauties of doing all this in 3D as opposed to doing it inside of something like a 2D environment. All right, let's go and open this guy up in its own window. Of course, you can make any type of modifications that you might need, but what we're going to be focused on is actually documenting this pipe route, because we're going to have to come in and fabricate this before we would install it. And one of the things that I like that is available here is the ability to define spools for a particular pipe route. And basically what spools do for you is it lets you split up your route into different areas. And that way you can have its own drawing or bill of material, and you can kind of track it separately. And to do that, it's pretty easy. What I'm going to do here is just enter into the define spools command. And basically, you just come in and select whatever points on the route that you would like to add to that particular spool. So let's say we wanted to fabricate all of this stuff up together. We could go ahead and we'll name that spool 1. We can click OK. And you can come in and just continue to define the areas that you want to fabricate separately just by selecting the segments of the pipe route. So let's say all of that will be fabbed up together. All of this might be fabbed up together. And then we'll come in and we'll do our 2-inch line right here separately. All right. There we go. And what we've done here, we've basically organized all of this into its own, into their own spools. So if you select this little spool folder here, you can see it highlights on my screen. That's spool number 1. Of course, you can expand that and see all the components and pieces of pipe that make it up. And then spool 2, 3, 4, and 5. And the beautiful thing about this is whenever it comes time to make a drawing, having those separate spools gives us a little bit of flexibility. And I'm going to show you guys an automated method to create a drawing of this pipe that's just super fast. So, of course, you can come in, you can select whatever spools you'd like to bring over into that particular drawing. We can select what drawing template we want to use. I'm going to go ahead and I'm going to create each of these individual spools. I'm going to create them on their own separate sheet. You do have some flexibility where you can put them all on the same sheet or even make separate drawings, but I'm going to kind of keep it simple and keep it all in the same drawing, but just on different sheets. All right, now take a look at what's going on over here. As soon as I click this green check mark, we'll kind of let the software do its thing. I'm not doing anything right here. I'm not driving or doing anything. Software is coming in and it's going to make a drawing along with dimensions for every spool that I have inside of that pipe route. So this is a great time to go and get a cup of coffee or something while this is working, and you're basically just letting the software do some work for you. Now, on each of these different spool sheets that we have here, basically what we've got going on is a bill of material that gets automatically created, and then you got the dimensions that get created here as well. You do have the flexibility to automatically add balloons as well if you'd like. So that functionality is available. Of course, you know, this usually isn't perfect. Sometimes you have to come in and manipulate some of these dimensions to where you can see them a bit more easily. But, I mean, it just did this automatically. So I'm not going to be too critical of it, you know what I mean? And then I also want to call out the fact that this bill of material is automatically generated. So this gives us our part number that we need, along with the cut length for all of the different joints of pipe. And it also gives you a spool reference over here in this column. So it'll let you know that this is all for spool 1. So pretty intuitive, pretty nice and automated method that we can use here. One of the things I want to show also is that all of this is fully associative, right? Just like anything else inside of SolidWorks. So what happens if we've got to come back in and make a change? Well, let's flip back into our main assembly. You can see here, let's say we have to shorten up this length of pipe. Now, if we shorten that up, it's going to also affect quite a few other areas of our pipe route. You know, that's going to shorten up this pipe as well. It's going to change up the distance between here. But the beautiful thing that's happening is that the software is going to take care of all that for us, and it's also going to take care of updating our drawing for us as well. So I'll go ahead and jump out of this route and flip back over into our drawing yet again. And you can see that this 4-inch portion, or this 4-foot portion right here, I just changed that up to 3 feet, and that updated automatically. So did all of the different cut lengths. So pretty nice, pretty nice flexibility and efficiency right there. All right, I'm going to flip over into the main drawing for this this route that we have, and you can see we've got a pretty decent sized bill of material, but we also have a few options of how we can group the piping in here. So you can come into your routing component grouping inside of that bill of material, and let's say instead of having every piece of pipe at the top level kind of split out into its own entity, we can group all of those pipes or tubes together. That way we can have kind of more of a conglomerate of the total length of pipe that we need for each spool. So here, this is just grouping in all of the total length of pipe that we would need for spool number 1, spool number 2, and number 3. Now, let's say we have to get this list of information over to our purchasing department. Well, we do have the flexibility to just save this out as an Excel document. So I'll just go ahead and save this out to my desktop. We'll call it a pipe bomb. Don't say that on an airplane. And we'll go ahead and click Save here. All right, let's open this up now that it's saved. And you can see that we've got a really nice looking bill of material. And we can even include a preview of what that component is. That way, you know, you can give a little bit of additional information to your purchasing department, maybe prevent an error from purchasing the wrong component of sorts. But really easy to share. You know, you got the length of material, so really nice and easy to give material takeoffs using this method. So I certainly do hope that everyone enjoyed this little overview of routing. Thank you so much for attending.